All right, if you would, go ahead and have out 2 clean sheets of paper and a pencil. 2 clean sheets of paper and a pencil. Powers Quiz 3, although we're going to be taking it as technically a roots quiz this time, we'll call it Powers Quiz 3. First and last name and today's date, and today is 4/13, 23, 4/13, 23. Re-recording this one from a couple years ago, so hi to Evan and Rocky and Jaden. Remember, no pausing, no rewinding, no replaying. Make sure you take it live, the same pace these students are in the classroom. No unfair advantages over the classmates in here that have to take it live. Hayden found out we were recording today, and so he skipped. But the ladies all made it. They were brave. So thank you to Danielle and Aubrey and Evie. Did he just show up?
I don't know. It sounds like
I don't know. Anyway, number down 1 through 16. Powers Quiz 3, number down 1 through 16. Again, I'll be giving you the larger number and asking you for the root. Number 1. What is the square root of 361? What is the square root of 361? Number 2. What is the cube root of 729? What is the cube root of 729? Number 3. What is the square root of 400? Sure, using cover sheets here in the classroom. I guess if you're watching at home, you don't necessarily have to. What is the square root of 400? Number 4. What is the cube root of 64? What is the cube root of 64? Number 5. What is the square root of 169? The square root of 169. Number 6. The cube root of 216. The cube root of 216. Number 7. The square root of 289. The square root of 289. Number 8. The cube root of 125. The cube root of 125. Number 9. The cube root of 512. The cube root of 512. Number 10. What is the square root of 196? The square root of 196. Number 11. The square root of 324. The square root of 324. Number 12. The cube root of 8. The cube root of 8. Number 13. The cube root of 343. The cube root of 343. Number 14. The square root of 225. The square root of 225. Number 15. The square root of 256. The square root of 256. And number 16, the fifth root of 32. The fifth root of 32. All right, let me go and collect those from you. Obviously, Jaden and Rocky and Evan, go ahead and email those in to me, and I'll get them graded. If everyone passed this quiz, then the quiz we take tomorrow will replace your lowest grade. If somebody failed, then obviously the quiz tomorrow will count. If you're watching a video, the quiz tomorrow counts. On the quiz tomorrow, you're going to have a mixture of both powers and roots. So I'll be mixing it up. I might give you, what is 18 squared, but then the next question might be, what's the cube root of 1,000, for instance? So it'll be both powers and roots mixed up on the quiz tomorrow. All right, if you would, go take out your homework handouts. Go take out your homework handouts. Reviewing over some things that we've talked about the last couple of lessons, talking about raising monomials to a power. Class, we said we had 3 steps to raise a monomial to a power. Sign, number, letter. And said we have 3 steps to take the root of a monomial also, class. Sign, number, letter. Quickly getting the handout out. Thank you, ma'am. Not wasting my time, please. All right, let's take a look at this together. And the top section there, we were raising to the power indicated. We need to remember that when we raise a negative, class, to an odd power, keeps its sign, so it would then be negative. A negative to an odd power is negative. What about a negative to an even power, class? Becomes a positive. What about a positive raised to an odd power? Stays positive. What about a positive raised to an even power? Still positive. So the only way you'll get a negative is if you have a negative to an odd power. And so as we look at the top section here, sign, number, letter, what did you get for your first answer, Aubrey?
225x to the 4th, y to the 18th.
Excellent job. 225, x to the 4th, y to the 18th is correct. For the next one, negative 3, x to the 4th, y squared, all cubed. Danielle?
Negative 27x to the 12th, y to the 6th.
Great job on that. Sign, number, letter. Be careful not to say 3 times 3 is 9, but 3 cubed, 27. Good job there. On the next one, kind of a weird exponent we got going on here. Let's see how Evie handled it.
64, a to the 30th, b to the 6x negative 6.
Great job. The negative to the even power becomes positive. 2 to the 6th we've memorized as 64. Raise a power to a power, multiply the exponents. 5 times 6, no problem. 30. X minus 1 times 6. That's a polynomial times a monomial. You distribute the 6. Excellent job, Evie. B to the 6x negative 6. And then for the last, we had a fraction raised to the power. No big deal. Just raise the numerator to the power and the denominator to the power. Aubrey, what did you get for your answer?
625 r to the 12th over 81 n to the 4th.
Good. A positive because negative is raised to an even power again. And then 625 r to the 12th. That's 5 times 5 times 5 times 5. And then the bottom, the 81 n to the 4th. Great job. Questions on the top section? Feel pretty good about that? All right, next section, we have roots. And we know we have roots, partly because in bold it says take the indicated principal root, and partly because we have that funny looking division symbol, class, called a radical sign. On the second and third questions in the section, we see a little 4 inside the crook of the radical, or a little 3. What do we call that number, class?
Index.
The index. It tells us which root we're taking, but we don't see an index on the first and last ones in this section. That means it is understood too. Good, Aubrey. The stuff that's inside the radical, the stuff you're taking the root of, class, is called the radicand. We need to remember when we take the root of the power, class, we
Divide the exponent by the index.
There we go. You kind of took the lead there. Class, let's say it together since that was a little shaky. Class, to take the root of a power, divide the exponent by the index. Couldn't hear you, Evan. Let's try one more time. I'm just picking on Evan because I can. To take the root of a power, class, divide the exponent by the index. Our unison effect not there. We are no choir, but that's okay. It's just a math class. Looking at the first one in this section, Danielle, when you took the square root of 324, a squared b to the 8th, you got 18ab to the 4th. For the next one, when you took the 4th root of 16m to the 8th, Evie,
2m squared.
2m squared is correct. Remember, if 2 to the 4th is 16, the 4th root of 16 must be 2. For the next one, the cube root. Cube root of negative 27x to the 12th, y to the 6th, Aubrey.
Negative 3x to the 4th, y squared.
Because remember, an odd root, class, always keeps its sign. So if it's an odd root of a negative, it's negative. If it's the odd root of a positive, which we didn't see any of those, but if you have the odd root of a positive, it would be positive. Odd roots keep their signs. What about even roots?
It doesn't matter. They always have.
Technically, right, if you take the even root, you get positive, negative. But it said the principal root, which means the positive root. But what if you try to take the even root of a negative?
You can't do it.
Can't do it. Remember, that'd be imaginary. Cannot take the even root of a negative. What about the last one here, the square root of the fraction, Danielle?
17a cubed over 19m squared n to the x.
It should be n to the z.
Sure, we'll go with that. I don't know why I did.
All right, right idea. Divide the 2z by 2 to get x, right? 17a cubed over 19m squared n to the z would be our correct answer. All right, questions on taking roots. All right, then we began looking at fractional exponents, class, and I said that a fractional exponent indicates a root in general, a root. Okay, it could be a square root, but a fractional exponent, class, indicates a root. What part of the fractional exponent actually is the root, though, Aubrey? The denominator is actually the root. The numerator, Evie, is just the exponent or the power. So when we see a to the 2/5, we can rewrite that, Evie, as?
The fifth power of a squared.
Not the fifth power, the fifth
Fifth
root of a squared. There we go. The fifth root of a squared is correct. How about the x to the 4/5? How would we rewrite that, Aubrey?
The fifth root of a to the fourth.
The x to the 4th?
Excellent.
The fifth root of x to the 4th is correct. On the next one, here we have the a to the 1/3, b to the 2/3. That becomes, Danielle?
The cubed root of a b squared.
Good, the cube root, not cubed root, but cube root of ab squared. Good. Nice thing is on a quiz or test, you don't have to say, you just have to write it. And then for the last one, x to the 5/6, y to the 1/6, Evie?
The sixth root of x to the fifth y.
The 6th root of x to the 5th y. All of those last two, by the way, worked out great because you already had the same denominator, so you already had the same index. What if they'd had different denominators? Would we go with two different indices? We'd get a common denominator so that we would still have just one index. Look at the bottom section here, rewriting with fractional exponents. Remember to take the root of a power, class, divide the exponent by the index. And how do we show that division if it doesn't work evenly? Fraction bar. So the square root of ab cubed becomes what, Aubrey? All right, well, let's look at it. We've got the square root of ab cubed, and it might help to write in understood numbers. We know that this index is actually a, and we know that the exponent of the a is actually a, and we know that to take the root of a power, divide the exponent by the index. So in each case, we're going to divide by the 2. What is 1 divided by 2? 1/2. There we go. And so we get b to the 3/2. Does that make sense? All right, so should have had a to the 1/2, b to the 3/2. For the next one, the 4th root of x cubed y, Danielle, it becomes?
X to the 3/4, y to the 1/4.
Excellent. X to the 3/4, y to the 1/4 is correct. For the next one, this one starts out innocently enough. Initially, Evie, what would we get for the next to last problem?
M to the 4/6 and n to the 3/6.
Good. M to the 4/6, n to the 3/6, but we don't leave it that way, Evie. How do we write our final answer?
N to the 2/3 n to the 1/2.
There we go. Now again, if we were going the opposite direction, we would get the common denominator and then rewrite it with that same index. But we want to leave our fractions always reduced. How about the last one on the page, the cube root of r squared, Aubrey?
R to the 2/3.
R to the 2/3 power is correct. Any questions on basic roots or basic powers? Any questions on it? All right, clear desk except for one clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. Clean sheet of paper and a pencil, everything else away. First and last name at the top of your paper, along with today's date, which is again 4/13/23. First and last name at the top of your paper, along with today's date, 4/13/23. Obviously, Jaden, don't put 4/13/23. Put the date you're actually taking it. But put the date at the top. And this is quiz 31. Quiz 31. Quiz 31. Let's go and take a look at the quiz together here. First section, true or false? Write the whole word true or the whole word false. Rocky, don't write liar, just write false, okay? If it's wrong. If it's true, of course, write true. Numbers 7 through 10, raised to the indicated power. Numbers 11 through 14, find the principal roots. Any questions before we begin? Should be pretty straightforward. Don't rush through the true, false. Make sure you think carefully through each of those. We'll end the video here, and then when we're done with the quiz, we'll start part 2 of this lesson.